Hello and welcome. My name is Emily Huerta, and I will be presenting on examining potential implications of climate change on Wisconsin fish distributions. As global climate change continues to be researched and predictions are made by experts, it is evident that ecosystems and the environment will take grave impacts. As winters shorten in Wisconsin and mean annual temperatures rise, natural habitats and the biodiversity they support will face adjustments in population distributions. This paper will outline recent and historical scientific evidence that examines the potential implications of climate change on Wisconsin fish distributions. In specific, walleye, largemouth bass, and both brook and brown trout distributions, their performance and trends will be analyzed to cover highly desired cold and warm water fish species in Wisconsin. The projections presented from previous studies have concluded that while all three species are expected to decline, walleye and trout populations will diminish with warming temperatures considerably more than largemouth bass. With largemouth bass and walleye perceived as the two most popular Wisconsin fish species, and trout being among the top 5, it is important to reflect on the implications of these predictions. Research that assesses the probabilities of population decreases can aid in future resource allocation, habitat preservation, and conservation efforts, and further restrictions based on these predictions. So, for my objective, my final research question was, in what ways does global climate change have the potential to influence distributions of walleye, largemouth bass, and trout populations in Wisconsin? And if so, to what extent and within what time frame are these implications and impacts going to be seen? So from there, I went ahead and the objective was kind of outlined in terms of comprehending the impacts of climate change on freshwater species, and then those specifically in Wisconsin. And then as stated, the three species were walleye, a cold water species, largemouth bass, a warm water species, and brook and brown trout, which are both a cold water species. So with methodology, with over 160 fish species in Wisconsin, I really needed to narrow it down in terms of what distributions I wanted to assess. First, I needed to determine the top 5 preferred species and desired species in Wisconsin for both cold water species and warm water species as matched controls for each other. I then read numerous articles and journals of climate change related effects on freshwater species overall. I read articles from Europe that were studying French trout populations, and then also looked at a couple more studies that were more local and proximal studies on Wisconsin and the Great Lakes region. From there, I explored the projected implications of climate change for Wisconsin walleye, largemouth bass, and trout populations. I synthesized these findings, discussed what these implications could mean, and then I recommend. So, for results, there were significant changes in stream fish populations projected, all to be in northern Wisconsin. Also to be in smaller streams, which are also going to be cool and cold water fish dominant species waters. And the least change is going to be seen in southern Wisconsin, where larger streams are more prevalent with higher degree days overall, and warm freshwater species are dominant in that water body. So this study that I'm referencing by Lyon, Stewart, and Mitro, in 2010, they examined 50 streamfish species in Wisconsin, and of these 50 sample species, 23 were projected to increase, 23 were projected to decrease, and 4 of those were projected to remain the same. So with decreasing, 3 of the species were cold, 16 of them were cool water species, 8 of which were 8, and warm 8 species were warm species, and then 8 were also stagnant species. So when taking a look at that increasing species in terms of the 23, those are going to be all warm water species. So every single species that's increasing is only a warm water species. Every single one of the cold water and cool water species we're going to decrease as well. All of the warm water species were going to be increasing in terms of population, partially due to their tolerance to a loss of habitat compared to warm water species. Additionally, when looking at walleye and largemouth bass, 58% of Wisconsin lakes were projected to be largemouth bass dominant lakes, and 85 resilient lakes are actually identified in Wisconsin that are going to be able to be resilient to extreme climate condition effects, and might actually be able to sustain walleye populations regardless of the increasing water temperatures and annual mean temperatures. So when we take a look at the three fish kind of broken down, walleye in general, large, low degree lakes with low to moderate shoreline complexity. So these walleyes are going to be projected, to be found in lakes that have a greater surface area, and they have a lower degree day overall throughout the year. So their intermediate conductivity is also going to be based on that low to moderate shoreline complexity. Additionally, 74 to 168 lakes, depending on what global climate model or global circulation model, is being used, whether it's going to be current or mid-century to late century predictions. 74 to 168 lakes in Wisconsin are predicted to no longer be viable habitats for these walleye. Looking at largemouth bass, they actually are going to be having an increase in potential habitat surface area. So with the increasing water temps and annual mean temps overall, those are also going to create warmer environments that can support and sustain these largemouth bass. So additionally, these lakes that were previously dominated by walleye will actually be likely to be dominated by largemouth bass then. And when we take a look at trout, brook trout actually are projected to have a 68% habitat loss, which is significantly more than brown trout, but that's also because brook trout are more vulnerable to habitat loss due to their temperature or their lower temperature thresholds. So brown trout can actually kind of withstand a little bit warmer of cool temperatures in a sense for water, whereas brook trout need the most cool conditions in terms of water temperature for their support or life support. And with trout, the highest concentrations are going to be in climate-resistant regions that are identified as the western driftless region of Wisconsin, as well as the Lake Superior Basin. And this is partially for the driftless region. This is due to the karst topography, and for the Lake Superior Basin, this is going to be due to the overall lower summer temperatures compared to southern Wisconsin. So concluding and taking a look at some of the limitations that my research has, fish have a significant or a variety of significances in the state of Wisconsin, whether that is cultural to indigenous populations or just cultural to an identity of being up north and being able to fish, or if it's economic and commercial. Fish have a really, really big cultural part in Wisconsin. And With climate change, natural and human environments are subject to a number of changes, and with everything on the Earth's surface, as I've mentioned, nothing is distributed evenly on the Earth's surface. So these impacts and these changes are going to be seen at different extents and in different places and distributions, which can be seen where we have largemouth bass increasing and walleye decreasing, and we're going to have more trout in northern, in the driftless region in northern Wisconsin in Lake Superior Basin as compared to other areas of Wisconsin. And while there were projected declines in all three species, there were increases in potential habitat for warm water species. And when we're taking a look at that study in 2010 by Lyons, Mitro, and Stewart, though there are 23 warm water species that are predicted to increase in populations, therefore it's also important to look at what those 23 species might impact in terms of food chain and ecosystem and just overall environmental changes and effects. It's also important to be able to recognize and identify and then act on these climate change resistant regions and ecosystems in Wisconsin. So those are going to be the 85 lakes that were identified in the study that are going to be able to support walleye populations despite the warming temperatures of water and air, as well as some of these regions such as the Lake Superior Basin and the driftless region that will be able to support populations despite the global climate change. As well, this is going to help in terms of figuring out where we can put funding and time and effort and just resources to preserve and conserve and just manage populations within Wisconsin right now. And in terms of the limitations of my research, I think it would be very, very interesting and I think very important as well. I think my research lacks that significantly in terms of the detailed environmental manipulations related to climate change. So understanding how the riverbeds will change in terms of climate change and how stream flow will, and how each of those little things are going to impact and could change the environments that we are living in and near. As well, I think it'd be really interesting to look into the food chain implications, as recently or previously mentioned, with those predicted increases in those 23 species of warm water fish. What will those implications be for food chain and other just space for other fish, and then other aquatic organisms as well? For those implications, will plants and other organisms be able to exist in the same ways they do now with those increases in warm water species, or will there be significant changes? So those are my limitations, and here are my references. Thank you for listening. I appreciate your time.